So this video is going to be looking at solving quadratic equations. It's going to be quite a broad brush, big picture type overview. I'm not going to go into the mechanics of, say, solving by factorization. I'm not going to guide you through step by step how to complete the square. I probably will do that in subsequent videos, but this is going to be quite big picture. And in particular, we're going to be looking at one particular method of solving quadratic equations, that's solving by factorization, and I'm going to guide you through the situations in which you'll be required to use a different method. So just bear with me. We're going to be looking at three different methods of solving quadratic equations. The first of these is by factorization. So within that you have three different methods. So factorization, generally speaking, it means putting into brackets, putting quadratic expressions into brackets, and there are three different methods by which you can do this. So you can either do it by taking out a common factor, by putting your expressions into two separate sets of brackets, or by using a difference of two squares methods, which again is putting your expressions into two sets of brackets, but it looks slightly differently, and the situations in which you're required to do this again is slightly different. If you just hang on, we'll be looking at that in the next part of the video, when to use each of these different techniques. But generally, going back to the bigger picture, so we have solving quadratic equations by factorization. That's your first method. Second method, so here, if the question specifies to leave your answer in surd form or exact form, or it asks you to leave your answer in the form A root B, anytime you see a square root or anytime you're required to leave a surd in your answer, then you're not going to be using your first method. You're not going to be solving by factorization. Your quadratic expression will not factorize. So in this case, two different methods of solving quadratic equations if you're required to leave your answer in surd form. The first of these is by completing the square, and the second of these is by using the quadratic formula. More often than not, if you're required to leave your answer in surd form, then you could use either of these two methods. Either you could complete the square, or you can use the quadratic formula. My advice to you would probably be to use the quadratic formula. And just one more point to note before we move on to looking at the different methods of factorization, those three methods up there. We more often than not, if you are solving a quadratic equation and it doesn't specify the method by which you're required to do so. So sometimes the question will say solve by completing the square, in which case obviously you'd have to use method 2. If the question just says solve, you can actually always use the quadratic formula. Even if it's quite an easy expression to factorize, then you can also use the quadratic formula. It might be actually more difficult to use the quadratic formula, but one thing to bear in mind is if you're struggling, if you're finding it quite difficult to factorize the expression that you're left with, and you're given the option, it doesn't specify which method to use, you can always use the formula. And the formula, you should have been using this from GCSE, so it should be something that's quite familiar to you. But if you just hang on, after the break, we're going to look at our three different methods of factorization. So that's using extracting a common factor, putting your expressions into two sets of brackets, or looking at your difference of two squares method of factorization. So we're going to look at our three different methods of factorization. Just remember what factorization actually means. The word factor, so factors of 24, obviously 4 and 6, both. If you multiply 4 and 6 together, it does give you 24. So factorization, it means splitting down into factors. So you notice here we have three quadratic equations, and then within each of these you have quadratic expressions on the left hand side. So your first objective, anytime you're presented with a quadratic equation that you need to solve, you need to move everything to the left hand side such that you have 0 on the right hand side. Alternatively, you can move everything to the right hand side such that you have just 0 on the left hand side. So, but essentially you need one side of the equation equal to 0, and then from here you're going to take a look at the quadratic expression you're left with on the other side of the equation. So you've noticed here I have my quadratic term and I have my term in x, so that's plus 5x. This second equation here, I have my quadratic term, so I have my x squared, I have a term in x plus 5x, and I have a constant term, so I have all three here. And then third one, I have a quadratic term and my constant, so no term in x there. Each of these is going to necessitate a different method of factorisation. So we're going to look at this first one here. So you notice I have my quadratic term and I have my term in x. First method of factorisation is factorisation using the common factor method. So here, all you need to do, you look at your x squared term, you look at your plus 5x term, you say to yourself, well, what is common to each of those terms? Well, it's clearly going to be x here. And just remember, factorisation, as far as quadratics are concerned, means putting into brackets. So essentially we need to put this, express this expression on the left-hand side as a combination of a product of two factors. And to do that, we're going to introduce brackets. So first step, what's common to each of these two terms? It's x. And then inside the brackets, so notice here, I have one term outside my brackets, and I have two terms inside my brackets for this particular expression. How do I get to my x squared? What do I multiply my x by to give me my x squared? Well, it's just x. And looking at the second term, what do I multiply my x by to give me plus 5x? Well, it's going to be plus 5. Okay, and then obviously the right-hand side stays equal to 0. And just note here that if that was a minus, then obviously there'll be a minus inside the brackets. My second term inside the brackets would be minus 5 rather than plus 5. And then just for completeness, let's solve this. So from here, you know that essentially these two multiplied together gives you 0. So this tells you either x equals 0 or x minus 5 equals 0. Okay, because if this is true, x equals 0, then this whole thing on the left-hand side must equal 0. So it satisfies that equation. Similarly here, x plus 5 equals 0. Sorry, I do beg your pardon. Then this thing will equal 0. That whole expression on the left-hand side will equal 0. Again, it will satisfy that equation. If x plus 5 equals 0, I'm going to subtract 5 from both sides. So x equals minus 5. So those are your two solutions. So that's first method of factorisation by using the common factor method. Second one here. So this first method, common factor, it only involves one set of brackets. So one term outside the brackets, two terms inside the brackets. Both of these two other methods involve two sets of brackets. Right, so here, two sets of brackets. Okay, so either if you're presented with a quadratic term, your term in x, and your number term, or alternatively, you look at this one here, and you're just presented with a quadratic term and your constant term, your number term, then it's going to be, each of these methods requires two sets of brackets. Then, obviously, factorising this, you know x squared. How do I get to x squared? It's going to be x times by x. Like I said, I'm not going to go into too much detail on actually the mechanics of factorising. I'll probably do that in another video. And then looking at this plus 4 term, what two things multiplied together gives me plus 4? Well, it's either going to be 4 and 1 or 2 and 2. How do I get to that plus 5x? Well, it's got to be plus 4 and plus 1, or alternatively plus 1 and plus 4. And then going back to here, so actually solving your quadratic, you know that either x plus 4 equals 0, in which case x equals minus 4, or x plus 1 equals 0, in which case x equals minus 1. So again, we have two solutions. Just remember, with quadratic equations, you can have either two solutions like this, one solution, i.e. equal roots, or you can have no solution at all. Again, we will look at this in further detail when we cover the discriminant and what the discriminant means. That will be in a separate video. So x squared minus 16 equals 0 here. Again, like I said, it's going to be two sets of brackets. Two sets of brackets. What's going to go into each of these? Well, again, it's going to be x and x. And here, you notice we have no term in x. We just have our quadratic term and our number term. How do I get to this number term? Well, notice this is a square number. And this will always be the case with square numbers. I can actually do this, x plus 4 and x minus 4 to give me that minus 16. So just, if you take a look at this, if I were to expand that out, I'd have x squared plus 4x. Okay, let's do this the other way around. So we'll say x squared minus 4x plus 4x minus 16. And you notice those two terms disappear and just leaves me with x squared minus 16. So I do indeed get to that. And similarly, if I had x squared minus 25 equal to 0, rather than 4 and 4, it will be 5 and 5. X plus 5, x minus 5 equal to 0. And then just looking at this, let's just solve this for completeness. So again, you know that either x plus 4 equals 0, in which case x equals minus 4, or x minus 4 equals 0, in which case x equals positive 4. Okay, so those are 3 different methods of factorisation, and just which method you choose obviously depends on which terms you're presented with. So if we have all 3 terms, it's going to be 2 sets of brackets. All 3 types of terms, so your quadratic term, your term in x, and your number term, it's going to be 2 sets of brackets like this, where your number terms here are going to be different. If presented with just your quadratic term and your number term, then it's going to look like this, where you have 2 sets of brackets, a difference of 2 squares, this is called. So you have your plus 4 and minus 4, or plus a number and minus a number. And then your third method here, common factor, when we just have our term in x squared and our term in x, and here you're extracting a common factor and then determining which the other two terms, which are going to get you back to this expression on the left-hand side there. Okay, so if you think back to the 3 equations we looked at previously, each of those had a quadratic expression equal to 0. So your first port of call, anytime that you know you need to solve a quadratic equation, you need to move all of your terms to one side of the equation such that you have a quadratic expression equal to 0. So each of those, the previous ones we looked at, they were already in that form. If they're not, then there'll be a little bit more work involved before you're actually able to factorise. So let's take a look at these. So here we have 3. These are quadratic equations, because your highest power in x will be x squared. Might not be able to recognise that just now, but essentially you need to rearrange it in the form ax squared plus bx plus c equals 0. I mean, all that means is basically you have all of your terms on one side of the equation. Okay, and then obviously that allows you to work out your coefficients on x squared, x, and your constant term. So you look at each of these 3. Currently, they're not in that form. We don't have all of our terms on one side of the equation and the other side of the equation equal to 0. So we need to get it in that form. So first one, how do we do that? I mean, there's 101 different ways to solve equations, rearrange equations, etc. But essentially, you can either move these 2 terms to the left-hand side, or you can move these 2 terms to the right-hand side. I think personally, it doesn't actually matter, just so long as you're following the rules of equation. Whatever I do to the left-hand side, I also need to do to the right-hand side. You maintain the value of the variables in your equation, and that's fine. Okay, so I think the easiest thing to do is to move these 2 terms over to the left-hand side. How do I do that? Well, I'm going to subtract 2x from both sides of the equation. I'm going to subtract 5 from both sides of the equation. So what you're left with is x squared plus 6x. Okay, so I'm going to subtract 2x from both sides of the equation, subtract 5 from both sides of the equation. Remember, we're just looking at the left-hand side to begin with. And then obviously that's the same as, if I collect my like terms in x there, I've got plus 6x minus 2x. How many x's do I have altogether? I've got 4 of them. Minus 5 equals 0. Now this second one here, so this is now in the form some lot of x squared plus some lot of x plus or minus a number. So remember, the signs on each of these coefficients could be minus, they could even be 0. So if my terms in x squared cancelled and I had that, then that would still be in the form some lot of x squared plus some lot of x plus or minus a number. But here my a would be 0. In other words, I have no quadratic term. That quadratic term disappears. But like I said, important thing to bear in mind here is that you need to be getting all of your terms on one side of the equation, which is what we've done there. Oh, there's my 0 gone. There he is. So that's the first one done. Second one here. Looking at that, obviously anytime you see this, so important thing to bear in mind here is that anytime you see this, more often than not, you're going to expand that set of brackets. The only exception to that is when you have, when you're solving by completing the square and you have something like this. Okay, here it's not necessary to expand the brackets. Here, your next step, you can quite simply do that and then square root both sides. Oops, don't need that there. Equals plus or minus square root of 7. So x would equal minus 3 plus or minus square root of 7. So I said, don't worry too much about this. This is solving by completing the square, and it's not something that I'm really going to cover in this video. I will cover it in another video though, so look out for that. But like I said, anytime you see something that looks something like this, more often than not, you're going to expand that set of brackets. So let's start off by doing that. So either you can write this out in full, x plus 3 times by x plus 3. That's what that means. Remember, anything squared means that thing times by itself. So we've got x plus 3 times by x plus 3. I'm just going to expand that set of brackets out. So x times by x gives me x squared. X times by 3 gives me plus 3x. And again, plus 3 times by x plus 3x. Plus 3 times by plus 3 equals plus 9. Minus 2x equals 3. Okay, I'm just going to invade that guy's space a little bit. So now, this should look a little bit friendlier. We're just going to tidy this up. So we have x squared. I'm just going to collect together my like terms. So I've got plus 3x minus 2x. So that's plus 6x minus 2x plus 4x. Plus 9 equals 3. Again, you can do this in several steps. You could probably even some of you can probably even do this in just one step. But I'm just showing vast majority of my working for completeness. Plus 4x. Now I'm going to subtract 3 from both sides. So move this over here. Essentially, subtract 3 from both sides gives me that. Okay. And now the last one. So important thing to bear in mind there is that anytime you have something that looks like this, more often than not, you're going to expand the brackets. Just divide these up a little bit. Last one here. So if we want to rearrange this in the form some lot of x squared plus some lot of x plus some number, basically anytime you have an equation involving a fraction, first port of call, first thing you need to be thinking about is how do I get rid of that fraction? So the way you do that is by multiplying both sides of the equation by the denominator of the fraction. So here I'm going to multiply everything through by 4. What does that look like when I do that? Well, first term I'd have 4x squared over 4, so those would cancel. So essentially, all I do when I'm multiplying, so those would cancel. When I'm multiplying this first term by 4, all that happens is the bottom of the fraction disappears, which is what we want. Okay, so that's the first term done. Second term, I've got plus x, and I'm multiplying that by 4, so that's obviously just going to be plus 4. This one here, minus 1, oops, sorry, that's plus 4x. Minus 1 times by 4 minus 4 equals 4. So now, all I'm going to do, plus 4x, going to move this term over to the left-hand side, subtract 4 from both sides, so I'm left with that, minus 8 equal to 0. So, and look at what we're left with. we're left with three equations in this form. So when it's in this form, you can either use, most of the time you're going to be factorising, but if you recognise that it doesn't factorise, you're going to be using the formula or completing the square. But I mean, really use the prompts in the question, because if you're presented, if you get down to this form here, and then the question says, leave your answer in surd form or leave your answer in exact form, then you know that rather than trying to factorise this isn't going to factorise, then you're going to use your formula. Okay? But important thing, just remember that anytime you're solving a quadratic equation, you're going to need to get it in this form where you have all of your terms on one side of the equation, i.e. One side of the equation, it doesn't matter whether it's left or whether it's the right, one side of the equation needs to be equal to 0. So just to summarise your key points here, first of all, use the prompts in the question. So if the question says leave your answer in surd form or leave your answer in exact form, you know you're going to be using one of those two final methods of solving quadratic equations, i.e. completing the square or using your quadratic formula rather than solving by factorisation. So use the prompts in your question. Number 2, one side of the equation must be equal to 0. So regardless of whether you're using solving by factorisation or using the quadratic formula, you know both of those methods, they require you to move all of your terms over to one side of the equation such that once the other side of the equation is just 0. In other words, expressing your quadratic equation in the form some lot of x squared plus some lot of x plus a number. So that's what we looked at in a previous section of the video. And then lastly, remember your three different methods of factorisation. So I've tried to give you a big picture overview here. So we've looked at three different methods of solving quadratic equations. And then within the first one, solving by factorisation, we've looked at three different methods of factorisation. So number 1, looking at your common factor. Number 2, factorising into two sets of brackets. Number 3, factorising into two sets of brackets where you have plus a number and minus numbers, i.e. x plus 4, x minus 4. So that's when you just have your quadratic term, so x squared, no linear term in x, so you might have something like x squared minus 16. Okay, so important thing to remember there is that when you've moved all of your terms over to one side of the equation, i.e. you have one side of the equation equal to 0, then you look at which terms you're left with, which types of terms you're left with, and that enables you to determine which method of factorisation you're going to use. So that was in the second part of the video. Okay, I hope you found that useful. And like I said, I will cover some more of these techniques in further detail in subsequent videos, but this should give you a nice big picture overview, either for revision purposes or if you're quite good with your methods of factorisation, mechanically, algebraically, you're quite strong. This should help put things into perspective for you. Thanks very much for watching, and don't forget to subscribe for more tutoring videos. Remember that full notes and other resources are available on my tutoring website at idktuition.com. And if you'd like me to cover anything in particular, please leave me a message in the comments below or on Twitter at TomDavies32.